I'm going to start talking about the Cosmos optical demo, where we actually built some programmability into the optical components of the testbed right now. For more information, you can find it on the Cosmos wiki page, where we have details of how we implemented all the code. So I'm going to do a little bit of repeating here about, well, in case some people miss some components of the system. But to understand the general idea of the whole Cosmos testbed is we need to we can either do computation for the medium or large nodes on site, or we can send it all the way back up to the top to a compute node higher up into the general purpose cloud, or we can make it an edge cloud as well. So based on these different options, we need to actually run the SDR and the SDN orchestration over the optical network. And therefore, the optical network is really needed for a lot of the AR, VR, edge cloud, or any of the orchestration that we discussed earlier this morning. Generally, the components of the testbed include a space switch, some ROADMs, some compute nodes, and a lot of the large and medium nodes that were previously discussed by King Jun as well as Yvonne and Gil earlier. But to make all the components work together, we need to actually make a fully computable, programmable optical network. And that was our first step here, is we're showing you how that actually is being done currently. So this is what's deployed currently, as King Jun just actually showed us. And we have a large space switch with different ROADMs and the co-location site at 32 out of the Americas that goes in a circle. So based on this, we can actually create a variety of topologies, even though it's basically a tree topology. By using the programmability into the optical network and the ROADMs and the space switch, we can actually create a wide variety of topologies that can make loops in the system to add different additional distances. For example, going down to 32 American in the back adds about 14 miles of latency, 14 miles, and we do it twice, we get about almost 28 miles of distance there. So we can do it a few times and add distances and add latency to the system. And we will go over those components. And now Arthur will discuss some of the optical components in the system.
Thank you, Craig. So we have on the Cosmos we have a variety of optical equipment that let us do the experiment with reconfigurable optical networks. And in order to support this reconfiguration, we have, for example, 10 gigabit tunable transceivers that launch the light into the optical network that you create. And then we have 25 gigabit Ethernet connection that connects, for example, top-of-rack switch with the compute nodes where you perform your baseband processing. And further, you can have a 100 gigabit connection for your FPGA that probably do the baseband processing of the signal. Further away, you would have a space switch, optical space switch. What is it? Well, imagine like all the telephonic switchboard, but here instead of wires, you have fibers. And this is a reconfigurable switchboard where you can treat it as a reconfigurable patch panel, where you can connect the fibers in a different way that you want to connect them. And then you have a lot of ROADMs. ROADMs is a reconfigurable optical add and drop multiplexer. Basically, let you do wavelength-specific optical network and topologies. Wavelength-specific meaning that you can shine with your laser from the transceiver on lambda 1, and it will have one topology and then follow one network, and you can shine with a wavelength of lambda 2, and it will form you another one. So basically, this is a lot of equipment to support different applications like cloud RAN processing, edge computing, and AR, VR applications. Here, this is the overall architecture that will be deployed for the Cosmos. Everything is centered around the central switch with a 320 by 320 ports. It has a lot of connections. It has connections to the large node. The large node as well has processing capabilities. And then you have the connection to the ROADMs, with the help of which you can form as well a variety of topologies. You can, for example, place one large node near to the processing unit, and then you could put another, for example, medium node several miles away from the processing unit, and you can configure them on the fly, and you can actually do the experiment by configuring optical networks on the fly as an set up in a dynamic way. So here, this is just interface of the Kelvin switch, or space switch with a 320 input and output ports. This is just a representation how do you connect physically the fiber. You just select some input-output ports, you add the connection, and it's there. Then another piece of equipment is a Rodent. Rodent, as I said, is something that lets you do wavelength-specific, optical wavelength-specific networking topologies. It has like three basic property sections. It's multiplexer, demultiplexer, and two amplifiers to amplify the signal. Because this equipment not only do the routing, wavelet routing, but as well amplifies the signal of optical signal, because there might be losses along the way. And for example, two boxes of them might represent you 2-degree ROADM node with east and west direction and add and drop ports. So you can add traffic, and some traffic you could just let through. Currently, what there is to operate this testbed is some Python script that allows you to add connection to configure the ROADMs. So, for example, to pass one wavelength to block another wavelength, to pass one wavelength from one port to another, and vice versa. And for example, today we are going to show you how to set up this ROADMs, but actually what is need to be done as well, just for practical purposes, is that the ROADMs require that there is one channel always flowing through the line import of the ROADM, and that's why we will set up a snake signal, snake path, which means that there is one transceiver and it's sending light to the ROADMs, and this light passes through all the ROADMs and ends up on the same transceiver. And we will talk about this further. I believe, no, not that. Okay, so this is a Cosmos test architecture of the prototype, which exists right now. There is in the central Kelvin switch. There are 4 ROADM boxes. 2 of them, if you combine 2 of them, they will form a 2-degree ROADM node. There is a connection to the Professor Zussman lab, which has a connection to the data center on 32nd Avenue of Americas, and it's physically separated from the Columbia University where this track is located, and it's separated by 7 miles. So the round trip distance is 14 miles. Then you have a connection to the top of rack switch, which has transceivers, tunable transceivers. You can configure the wavelength on each transceiver. And then you have the connection from top of rack to the compute nodes. You have two compute nodes for the core and 4 compute nodes for the large node. And then you have a connection to actual radio node, which is the large node, and the medium node. And so this is the first part of experiment I was talking about. In order to operate ROADM, you have to have on the line input port some light coming in. So what we do basically is just setting the transceiver and sending them through each ROADM on the circuit, and we go back and we end on the same transceiver. This helps us to operate the ROADMs and to build any topologies that you want. And actually, this is a part of the demo and Craig will help us to show this. So this. Currently, we are logged in a remote computer.
Yeah, hold on. So first, we recently built the snake switch. So now we're actually going to disable it.
Zoom out. Meaning, use the font. Yeah, but now do the font. Yeah, there you go.
Let's see. Remove snake. Remove snake.
Yeah.
So now we're going to actually send commands to remove the snake that's we previously built, but we'll show you how to rebuild it again. So we actually developed code that will add all the 8 connections that were previously shown if we actually have internet connection that's still running here. Let's see. Oh, did it start? Yes, we didn't have internet connection apparently. Let's try again. Apparently there's no internet. Okay, so apparently we don't have internet connection. Not anymore. Let's see. What? I'm on Wi-Fi, that's why. Give it dongle. We're changing dongle for Ethernet.
You won't get wireless. Do you get the wireless?
What?
Do you get the wireless?
Let's try again.
Failing on your machine, or is it failing on the VM?
Seems to be. Should be. It was working 2 minutes ago.
Yeah. Yeah, if this isn't the Wi-Fi here, it's something on the phone.
Something on your end.
This never happened before.
Andrews could be fine.
Just check the team view. It seems the user just logged out. So I'm not
Like,
sure.
ever reading SSH protocol banner, probably something wrong with the connection too. Yeah. Well, now we know it's a demo. Wait, so,
Oh, there we go.
Oh.
Now it's working.
You see there successfully deleted connection?
Now we have. Now it's finally working again.
Yeah. So these lines just show us that the previously built-in connection that was snake was deleted now and successfully.
So basically, we were trying to add the different connections on this. So we had to actually remove the connections from all the rodems. So all the drop lines that we have across here are the ones we add. The line in, line out are controlled by the Calian space switch that we pre-programmed previous to the experiment. But the line in and line out, the drop lines that go through the mux and demux are the ones we add and drop to create the connections for the full topology. So now we will go back and actually try to add them back in and see if it works.
do you have a team viewer?
No, he has it. Which guy has it? Come on.
Just get it done. Just time off. We can wait for the banner and some comments. Something else that says about based on the two things in the messages on there.
There we go. So first we have to disable the laser, that automatic laser shutdown. So once we disable that, we can actually turn on, send signals through the line in, and then it'll reprogram each of the 8 connections we just showed there. So we're actually looking, while it's doing something, maybe. We're trying to add these lines back in. So we're trying to add from ROTEM 4, this ROTEM 4, we're trying to add the drop lines from the top rack switch. We're trying to add the line through lines through the ROTEM. We're trying to add ROTEM 2 line 1 through, as well as the ROTEM 3 line 4 drop lines, adding drop lines here. So we're trying to add these 8 connections back in to enable the snake that goes around to
Just leave it. Yeah, turning on. Okay. Very good.
Can you test if everything's back up and running correctly? So we actually can check it remotely by typing this command here, and we can actually see the input power of one of the Rodents is -13, and the output power is -17. In addition, for the other mucks, the input power is -2, but there is no output reading on the demuck side, so the output power is always going to read -65. We can actually, based on the commands that we sent in, you can actually configure the demuck connections here, as well as the start frequency, the end frequency, and input power. So these are all actually pre-programmable commands that we actually send through our Python script.
Comment. Like I want just like comment on the frequencies. Here we set up the frequency, but actually these are optical frequencies. And for example, to the set of the wavelength 1553 nanometers, that means it's around 162 gigahertz. So we have to actually put the bandwidth of the signal that we want to pass through and to direct with. So we have to have actually a little bit transformation, but these switch are working with the frequencies.
The second thing we're trying to set up is we'll have a client, an edge cloud, and a central cloud. So the client it's one of the compute nodes, which connects to one of the top rack switches, which we pre-programmed into the system before we started the experiment today. All the details of that are in the wiki. And now we're going to show a topology where we're going to try to build a connection from ROADM 4 through the line inline outlines to ROADM 1 down to a drop line to link 1. So this will create a topology where we can have a client, and we also have an edge cloud computation device sending the information to that device. So now if we go back to the command line, we can no connection. Yeah. Favorite one, step A. So we're going to attempt to reconnect, make that connection we just discussed. So here we actually have the large node, the server compute node 2, and we're going to try to actually ping the one that's at 192.168.1 once it's actually connects to the cloud. But it seems that we're not connecting.
For example, if you need the wired connection here, you have a adapter.
No, but it's worth it. As soon as you have those, you can talk to the machine out there.
No, we cannot talk to currently the machine.
No, but I'm saying it's piping.
There we go. Nope, that's, right failed, broken pipe.
So currently we are logging into the Cosmos console, and from the console we are logging to the compute node to run our experiment. And now we are logged into the compute machine to the server 1 to top of rack 1 simulated, and now we're running a ping, which is not successful because
this command still didn't listen to us. Some SSH issues connecting right now. This actually connects. We will actually have Is it working from your machine?
This is the node phone just lost connection, so I'm not sure what's wrong with it. So that's why I think it doesn't work.
Okay, we'll see. Yeah.
Can you connect them?
No.
What's
I
happening?
tried twice.
Can you ping them? 100. Can you
Yeah.
ping the?
Mike can ping them. Yeah.
You cannot ping.
I can.
You can.
Even 4?
Yeah.
Okay.
The 3 are good, except for the last one.
What's-
And the thing that you running at working.
It's not connecting to the internet, that's why.
No, here.
USSH in. USSH in.
Yeah. Let's see. Try to disconnect this one.
This is apparently why you don't run a full demo. But anyway, earlier we were able to get full pings of 0.1 milliseconds if you do a connection here. But for some reason, it's not connecting to all the ROADMs
Just
currently.
It's not far, it's not. There's some people that's right, I'm talking, I know you think that.
Well, yeah, it's too hot to right.
Yeah, so we're should be programmable.
Did anyone move the node?
What do you mean?
Like maybe the connection something.
Tell us what you meant to do, and
Yeah.
hopefully.
So anyway, we're supposed to have a connection. Switch the connection between client 1 and the edge
into
cloud,
the-
and then
here,
client
in the
1 and
connect
the
switch.
central cloud. So we're trying to build 2 links here and program it through our software. But if we actually had connections, that would be helpful. So when we're programming the top rack switch, we have to actually add a top rack switch. We have to program the interfaces to send on the transceiver to send on a certain frequency, so that we can actually go through the ROADMs itself to build the topology. And we set the same frequency and channel for that's on the transceivers. It's the same one on the ROADMs as well. So those need to be the same in order for the signals to be successfully sent from the transceiver to go through the ROADMs and then back out the other direction to the other transceiver on the other top rack switch. So here we can see an example here. As we tried to show you before, we tried to establish link 1, which goes from the client to the edge cloud. And we assume that we have a connection from the line ports of ROADM 4 and ROADM 1, and similarly a connection from the line ports of ROADM 2 and ROADM 3 using the Caliant switch, which is pre-programmed. So our steps would then be to add on the mux and demux connection of ROADM 4 to the top rack switch 1. So we would add a connection from here to here. And similarly, we would add a mux demux connection from ROADM 1 to the top rack 2 to add on the drop and add side. And that will create a full topology. So we can see here an example of our code. So we're supposed to add a connection here. We have the IP address of the ROADM we're trying to speak to, the mux or the demux we're trying to speak to, and then the ports that we're trying to connect to on the line in and line outside. So for example, the 4102, if you want to program on the second mux line going in, is 4102, so we have that there. And to go on the line outside, you would go to the 4201 as the programmability of it. In addition, we input the wavelength, and then the full connection should be built, assuming we have a good connection via shell to the ROADMs, but apparently we do not right now. Similarly, it can be seen on the going through the preamp and the demux side, where 5101 is the label for the preamp, and then 5202 is the label for the line outside of the demux.
Okay.
If everything was established correctly, we would have on this short connection, we have about a latency of 0.1 milliseconds. If we were able to ping the machines correctly. Now, if we were to establish link 2, we would do the same thing, but we would add a couple extra lines of code in here to connect ROADM 1 and ROADM 2. Instead of dropping from ROADM 1 down to the top of rack 2, we go from ROADM 1 to ROADM 2. And that can be seen in these lines here. And the correct ports are labeled. They go from line on the out line 1 and add line 1. And similarly, we go through ROTEM 2, and the similar port numbers will be established. And then when we go to line 3, which actually goes through 14 miles of fiber to get to ROTEM 3 in each direction. So we actually have roughly a 28-mile round trip between the client and the central cloud in this case. And once that link is established, we're actually able to get 0.4 milliseconds of latency, which it lines up with the speed, close to the speed of light and the properties of the optics to get on top of the overhead delay that's already built into the system.
Can you try now and see if it's passed through, because it seems that everything should work. And can you add the connection, the experiment 1? Yeah, like that.
We'll see if it works.
Because we're checking in now, and for example, the snake connection is running, and for some reason, just we cannot connect.
Then the optical banner SSH is either responding with something else or not responding.
One of the ROTEMs isn't responding.
Can you get the information from the ROTEM 4?
Or it's responding with something that you don't expect.
Yeah, something.
That just goes there.
Yeah, one of the ROTEMs isn't responding. The first ROTEM.
Can we show just a? Can we show the
This is actually just showing that it's possible to set up the topology.
Well, we just have the topology at least. I think the commands connecting to ROTEM 4 are the ones that aren't.
Can you launch the TeamViewer?
No, not TeamViewer.
Okay, we'll debug it later.
Can we
Fine.
just show the screen and show that, for example, we get the power reading from the ROTEMs?
Yeah, if you can connect to this one,
yes,
it
we
works
can
on that
connect.
one, that's fine.
And remember, modems are notoriously dangerous to play with. I'm emphasizing it.
Yep.
You drink it to buy it.
So
Step 1 is disable.
25K, so it's not a big deal.
searching. Is it?
Let's
okay.
Yeah, exactly. You're going to be registered forever.
Okay, so what we see here, this is just a panel to observe the power levels going into the central Kelvin switch. And as you remember, the Kelvin switch is the center around all of the optical topologies, so we do have the opportunity to see the power levels of a signal. And here we can have just three red circles, three red squares, and they represent actually the transceivers that we wanted to use to show you the ping, but unfortunately we could not. But otherwise, we have a lot of all of these green lights, which means that the power flowing through all of the ROTEMs according to the snake that we set up, and actually we did succeed in controlling the ROTEMs. And we do not see the success from the code, but we do see from this panel. And here we actually can read the power levels that's flowing from the ROTEM and out of ROTEM. And for example, here we have the connection IDs, and you could find, for example, the description of this connection ID on the wiki, and to see that indeed the power and the light is flowing. Well, thank you.